Welcome back. Today we're going to be talking about how to find the mean absolute deviation, or the MAD, of a data set. So let's dive in. So to find the MAD, we are going to have to do 3 steps. First, we need to find the mean of the data set. If you don't know how to find the mean, there is a video that I've made as well for the middle school math series on mean, median, and mode, so that will go into more detail on that. But to make a long story short, we're going to add up all the values in the data set and then divide by the number of values. So if there's 5 values, we'll add those 5 values up and then divide that sum by 5. The second step is to find the absolute deviation. So basically to take each value, subtract that mean we just found, and then take the absolute value of that number. And then we need to, last but not least, find the mean of those absolute deviations that we just calculated. And the mean of those absolute deviations we just calculated would be the mean absolute deviation overall. All right, let's do the first example here. It says to find the mean absolute deviation of the following data set, 4, 5, 6, 6, 7. So first thing I'm going to do is I'm going to add up all these numbers and then divide by 5 because there's 5 numbers. Number 1, 2, 3, 4, 5. So let's do that. So the mean is 4 plus 5 plus 6 plus 6 plus 7 divided by 5. And now I'm going to add them up. So 4 and 6, that's going to give us 10, plus 11 is 21, plus 7 is 28. So this is going to be 28 over 5. Or if we want to put that in a decimal, we can use our calculator to do 28 divided by 5. Or we can say, well, 5 times 5 is 25. So then it's 5 3/5, which is 5.6. And I will say, feel free to use a calculator throughout this if you'd like. In general, for mean absolute deviation and just any sort of statistical concepts in general, it is pretty standard to be allowed a calculator on a test. So there we go. There's our mean. Now I want to find the absolute deviation. So I'm going to take each of these numbers and I'm going to subtract the mean and then take the absolute value. So the first one would be 4 minus 5.6, absolute value. The second one would be 5 minus 5.6, absolute value. The next one would be 6 minus 5.6, absolute valued. The next one we're going to do 6 again. Since 6 appears twice in this data set, we do need to find that same one again a second time because it is in the data set twice. And then we have 7 minus 5.6, and there we go. All right, and as a reminder what the absolute value means, essentially the absolute value is the distance from 0. So if we have a positive number, the absolute value is just that number. And if we have a negative number, then the absolute value is the positive version or the opposite of that number. So 4 minus 5.6 is going to be negative 1.6, and the absolute value of negative 1.6 would be positive 1.6. 5 minus 5.6 is negative 0.6, and the absolute value of that would be positive 0.6. 6 minus 5.6 is going to be 0.4, and absolute value of 0.4 is just 0.4. For this next one, I'm just going to repeat what I wrote up top because it'll be the same a second time. And then 7 minus 5.6 would be 1.4, and the absolute value of 1.4 is 1.4. Okay, so now we have essentially a new data set. We have the set of the mean absolute deviations, which is right here. And what I'm going to do is find the mean of these to find the mean absolute deviation. So the mean absolute deviation is equal to 1.6 plus 0.6 plus 0.4 plus 0.4, or you can write 0.4 times 2 because it appears twice in the list. Just make sure that you do include it twice. And then plus 1.4, and then we're going to divide all that by 5. So now feel free to grab a calculator if you'd like to, and let's add them all up. So if we add them all up, 1.6 plus 0.6 plus 0.4 plus 0.4 plus 1.4 is 4.4. So we have 4.4 over 5, and you can punch that in your calculator and get 0.88. So therefore, the answer for the mean absolute deviation of this data set is 0.88. 0.88. And because that's a relatively small number, what that tells us is that this data set is relatively close together, right? This is a number less than 1. And so that means that the values on average are pretty close to the mean. Whereas if we had a larger number, then that would indicate that some of the data points stray further from the mean, that there's maybe more outliers, or at least, more, either more outliers in some cases, or in others, it just means there's more kind of variety of the general data set that we might have. We have some values that are further from the mean than we would in this data set. All right, so here's another one. Here's another bit of a more challenging data set. We're going to do the exact same steps here, though. First thing I'm going to do is find the mean. So the mean is going to be 8 plus 3 plus 5 plus 2 plus 9 plus 22 plus 1 plus 8 divided by the number of things, 1, 2, 3, 4, 5, 6, 7, 8. So divide that by 8. So I'm going to add all those up. Let's do it. 8 plus 3 plus 5 plus 2 plus 9 plus 22 plus 1 plus 8 is 58. So that's going to be 58 divided by 8. And that is 7.25, which we can find from our calculator. Or we can say, well, we know that 8 times 7 is 56, so that leaves us with 7 and 2 eighths, and 2 eighths is 1/4 or 0.25. So we can also do it in our head that way too if we prefer. Now I'm going to find the absolute deviations here. So let's do that. So first I'm going to start with 8. So absolute value of 8 minus 7.25. Then absolute value of 3 minus 7.25. Absolute value of 5 minus 7.25. Absolute value of 2 minus 7.25. And then we have absolute value 9 minus 7.25. Then the absolute value of 22 minus 7.25. Notice that 22 is a much larger number. It's much further from this, and so that is going to sway the overall mean absolute deviation up. Then we have 1 minus 7.25 absolute valued, and 8 minus 7.25 absolute valued. So now I need to find all these values so we can find the average of them to get to for the mean absolute deviation. So 8 minus 7.25 is going to be 0.75, and the absolute value of that will just be the positive version. 3 minus 7.25 is going to be negative 4.25, but since we're absolute valuing that, we're going to make it the positive version there. 5 minus 7.25 is going to be negative 2.25, and the absolute value bars will make that positive. Then we have 2 minus 7.25, which is going to give us negative 5.25, which then becomes positive when we take the absolute value. 9 minus 7.25 is 1.75, and absolute valued is just the same. 22 minus 7.25 would be 14.75. 1 minus 7.25 is negative 6.25, which will end up as positive 6.25 after the fact, after we take the absolute value. And 8 minus 7.25 is, once again, 0.75. So I know we did do this calculation twice, but that's good because 8 came up in the data set 2 times, and so we are supposed to indeed do it twice because of that. Okay, and now I'm going to find the actual mean absolute deviation here. So the mean absolute deviation is going to be adding up all these numbers and dividing by 8. So 1.75, because I'm starting up here, plus 14.75, plus 6.25, plus 0.75, plus 0.75 again down here, plus 4.25, plus 2.25, plus 5.25, and all of that is going to be over 8 because there's 8 numbers overall. So now I'm going to grab my calculator and we're going to figure it out. So let's see, 1.75 plus 14.75 plus 6.25 plus 0.75 plus 0.75 again plus 4.25 plus 2.25 plus 5.25 is 36. So we have 36 over 8, which if we divide that by 8, we get 4.5. So this is a much bigger number than before, indicating that these numbers are more spread out. They're further, on average, further from the mean than in the previous data set because the mean absolute deviation was larger. As always, if you do have any questions, feel free to put those down in the comment section, and we'll see you for the next one.